let's look at the fifth question on the 2001 AP Calculus AB free response section. So it says a cubic polynomial function f is defined by f of x equals 4x cubed plus ax squared plus bx plus k, where a, b, and k are constants, so that's important. And the function f has a local minimum at x equals -1, and the graph of f has a point of inflection at x equals -2. So before we look at a and b, this sentence right here, this last sentence in the question, gives us some very important information. So if the function f has a local minimum at x equals -1, what that tells us is that f prime of -1, right, at -1, it has a local minimum. So f prime of -1 is equal to 0. Because when you're at a local minimum, the slope of the tangent line is equal to 0. And the last sentence also tells us that the graph of f has a point of inflection at x equals -2. And what that tells us, right, if it has a point of inflection at -2, that means that f double prime of -2 is equal to 0. Because if we have the graph of f double prime and it changes signs, that point refers to a change in concavity on the graph of f. So I've rewritten our important information up here. And now what we want to do is use this information by finding f prime and f double prime and plugging in -1 and -2 respectively and setting them each equal to 0. We want to do all that so that we can find what a and b are equal to. So let's start by finding f prime, plugging in -1 and setting it equal to 0. So if we take the derivative of that, we're going to have 12x squared plus 2ax, right? Remember, a is not a variable, it's just a constant, so we don't really worry about that. We just move the 2 to the front. So 2ax plus b, and then k is a constant, so it's just going to be 0. So this is our equation for f prime. And now what we're going to do is plug in x equals -1, because remember, f prime of -1 equals 0. So we're going to have 12 times -1 squared is just 1, plus -2a, right, because x is -1, and then plus b, and that's all going to equal 0. So from here, we still have this a and this b that we have to solve. So there's nothing we can really do with this to find the value of either one of them. We need another equation. So that's where we find f double prime, plug in -2, and set it equal to 0. So now let's find f double prime. So we take the derivative of f prime, and that's going to be equal to 24x plus 2a, right? Because this is 1 minus 1 just becomes 0, or becomes 1, so plus 2a. And then b is a constant, so that's going to be 0. And now we can plug in x equals -2 and set it equal to 0. So 24 times -2 is -48. Then we're going to go plus 2a equals 0. And now we only have a, so we actually are able to find what one of a or b is equal to. In this case, we can find a. So we just do a little algebra. 2a equals 48. Therefore, a equals 24. So we found what a equals. Now, we can use this equation for f prime of -1 equals 0, and we can plug in our new value, a, which is 24, to find b. So let's take this and plug in a equals 24, and I'll kind of move it over here. So we're going to have 12 minus -2 times 24 is -48, plus b equals 0. Then we do a little bit of algebra. We're going to have b equals 36. So a equals 24 and b equals 36 are our final answers for part A. Now that we've finished part A, we can get started with part B. So part B tells us that, or it asks us rather, if the definite integral from 0 to 1 of f of x with respect to x equals 32, what is the value of k? So with this information given in part B, we know that, or I'll write in blue for B, we know that from 0 to 1, or integral from 0 to 1 of f of x with respect to x is equal to 32. And therefore, let's call the antiderivative of f of x big F of x. So that equals antiderivative of f. So, or f of x. So we know that f of 1, or big F of 1, minus big F of 0, so the antiderivative of f of x of 1 minus the antiderivative of f of x of 0 is going to be equal to 32. So first, let's find what the antiderivative of f of x is equal to. So we're trying to find big F of x. And to do that, we use our integration rules, and we know that the antiderivative of 4x cubed is x to the power of 4. And if we think about that, we kind of check it. If we took the derivative of x to the power of 4, it would be 4x cubed. So there you go. And then it's going to be plus a times 1/3 x cubed. Because if we take the derivative, we'd have 1a times x, a times 1x to the power of 2. So a times 1x to the power of 2. And then we're going to do plus b times 1/2 x squared. And that works. And then plus kx, because if k is a constant, then we just add an x to it when we're taking the antiderivative. So then our interval is 0 to 1. So we only want x and k here, right? Because we're plugging these numbers in for x and we're trying to solve for k, but we still have a and b. So what we're going to do is take our values from part A and plug them in here. So we know a equals 24 and b equals 36. So once we plug those in, we're going to have x to the power of 4 plus 24 times 1/3 is 8 x cubed plus 36 times 1/2 is 18. So 18 x squared plus kx. And our interval is still 0 to 1. So now finally we have to solve by doing this, which is big F of x, and plug in the b of our interval, right? This is b and this is a, not associated with this a and b, obviously. It's just the start of the interval and the end of the interval. So we're going to do big F of 1 minus big F of 0. So now let's plug in those values and solve. So I'll write in green, I guess, try to keep everything separate. So if we plug in 1, we're going to have 1 to the power of 4, which is just 1, plus 8 times 1 to the power of 3, which is just 8, plus 18 times 1 squared, which is just 18, plus k times 1, which is k. And then we're subtracting big F, this is big F, right, of 0. So that's going to be 0 plus 0 plus 0 plus 0. So, and we can't forget that equals 32, right? Because it told us the definite integral from 0 to 1 of f of x with respect to x is equal to 32. So maybe I should have been writing that the whole time. They're all equal to 32. So now to solve this, we can just do some algebra, simplify it, and we can have 9 plus 18, which is 27, plus k equals 32. And now the hard part, you have to do 32 minus 27, which is 5. So we found that k is equal to 5. Thank you for watching. I hope this video was helpful. And if it wasn't helpful, if it was maybe confusing at parts, or you have specific questions about certain parts of the video or parts of this free response question, I hope that you would comment them to let me know. And thank you again for watching, and please like, subscribe if you enjoyed the video.